Good morning, Eric. We've got a few people joining up here. We got a couple minutes to go. How are you this morning in Arizona?
Wonderful.
Good. And you've been traveling a lot. You were just in Cleveland for the show we participated in there.
Cleveland was nice. Cleveland was a good time. That was a pretty nice show.
Yeah, that's now called Contractors Leadership. It used to be called Comfort Tech. We had a lot of interest in our booth, didn't we?
A lot of interest. Everything went really well. That was a rather enjoyable. That was a really enjoyable show over there. Wasn't overwhelmingly huge or anything like that, but it was productive.
Yeah. That was fun. And then you're headed today to the Carolinas.
Yeah, Raleigh, North Carolina. We've got about, what was enrolled was 120 contractors.
Wow.
We've got 2 sessions, one in the morning and then one in the afternoon. And that ought to be good. That's going to be definitely a full schedule.
120 contractors. That's wonderful. Let's see, I've got a little bit of an embarrassing picture I could show from last week's trade show in Cleveland.
Embarrassing pictures?
Shall I try to find that? It was you with some of the featured people at the Rock and Roll Hall of Fame.
Is that right? No, we better not do that.
So if anybody wants to see that later, just send me a chat and we'll we'll see what we can do. Very good. So we've got Caroline on, John from Bay Area Cool, a couple other familiar names here, so that's great.
John from Bay Area. Hello, John. How are you, sir?
He can't answer, but he can chat. Or I can promote him to a panelist if you want to answer. Should I do that?
Just thought we'll let him know that we'll probably see him. We're going to be in Boca Raton. What is that? That's October the 15th through the 18th.
Yeah.
Oh, and I am going to be at that the other meeting in Tampa.
Oh, that's right. That's right.
I'm not sure if they're going to be there, but we're going to be in Tampa as well on the 12th, I believe that is.
Very good. And on our website under news, you can see all the upcoming trade shows and locations where we'll be. So that'll be good. Very good, Eric. Well, I'll let you formally introduce yourself and get this started.
You want to get rolling already? You want to give it a couple minutes?
Yeah, you want to give it a couple more minutes?
Yeah, let's give it a couple secs. They're still
good
in here. It's only what, 6:01, so
6:01 your time. My goodness, that's early.
Well, you know, we're gonna go on this one. We're gonna go through proper probe placement. Try saying that 3 times fast, you know. But we're going to go through some proper probe placement and profiling. It seems like everybody has questions about profiling and probe placement, you know, so it's not going to be an extended meeting today, but presentation per se. It's going to be informative though, but it's not going to take all that long to do this, so. In just a moment, we'll get rolling. Give it 1 more minute.
Very good. And why don't you attendees try to send a little chat and say hello, and let's make sure everybody knows where the chat feature is. That's how we'll be taking questions and answers and comments throughout the presentation. So you should see your chat bar, and you can choose to either chat just to panelists or to panelists and attendees, depending on what your question or comment is.
Actually, when you use chat, address the question to everybody, you know, so everybody sees it just in case, so that'll answer anybody else's question if they've got the same one in their minds. So
very good.
I'd be a better shot.
Good morning, Caroline. Send us a little chat if you can. Hi, Shane. Thank you. Good morning.
I was speaking to Shane. I'm not sure if it's the same Shane, but there was a question regarding wireless thermistors.
Yeah, I was just thinking about that. Let me look up and I'll see if it's the same email. Yes, it is the same Shane. Thank you, Shane.
Good morning, Shane. We got a squeaky chair.
All right, John, good morning. Caroline, Ken, very good. Vales and somebody, ampersand. I don't know that ampersand is actually your last name or your second name, but hello from Virginia.
We got Mr. Barkman online too. Good
Very good. Very
okay,
good.
well, you know what? Let's go ahead and get started. Of course, I'm not sure if you already know me. My name is Eric Urrutia. I've been with North Park now since just about the beginning of the iManifold platform. I've been in this industry over 25 years, between being a technician, electrician's apprentice when I first got into working as a kid, and went from technician to into the wholesale industry, and now into manufacturing and technical. So I've got a pretty long history in this. But today we're going to go over some probe placement, and also we're going to go into equipment profiling. That I'm going to show you how to do this real fast. You'll be able to have your profile set into your iManifold program. That way it'll be so much faster for you to get onto the job and get moving on the job.
And Eric, before you get rolling, we have to say good morning to Nick from Melbourne, Australia.
Oh, wow. Good morning, Nick.
How about that?
I wonder if that's the same Nick that we met over in the HR.
Yeah, let us know, Nick, if we saw you at the HR show in Vegas.
Las Vegas. Okay, so first off, probe placement. When you're placing thermistors onto the piping, it's going to go basically the same as what you probably learned from getting into the business long ago. Our thermistors, this is a strap type thermistor. On the underside, I'm going to get this up to my camera here. On the underside is actually the thermistor itself. Now, using these, you're going to place them just like you would hands on a steering wheel, 10 to 2, up on top. You don't want to get any readings of the oil traveling or any settlement of the oil, so up on top, 10 to 2. They are flexible straps. These are not Velcro. They simply wrap up over the top, and there is a pinch. As you can see, the little triangulated pinch. This just pulls up over the top, pull it down, and it's all set. It's on there. Very easy. They're very quick. There's also the clamp type probe, and the clamp probe it has the exact same thermistor, and these are actually made by Cooper Atkins for us. Here's the clamp type probe. As you can see inside, there is the same thermistor that we have on the strap probe. So either way you choose, same thing. You got about an inch and an eighth on diameter that you can work with on this one. On the strap probe, you can go up to about a 5-inch piece of piping. So a little more versatile. It takes about a second longer to apply that strap probe, but all in all, I think it's a more versatile thermistor for what you're doing. Does anybody have any questions about the thermistors for the piping? Nothing going. Okay, perfect. One of the questions that always arises is where we put our temperature and humidity probes. These are our wet bulb, dry bulb for measuring airflow, air temperature with relative humidity. Now, on the probe itself, you'll see that there is the nameplate with the power switches, and then on the back side is your battery cover with the serial number and everything else. Now, at the end of this probe here, this is where your sensor is, your sensor tip. If you just briefly take a look and you unscrew the end of your your sensor tip, it'll expose the actual board. Okay, let me put this contrast on my shirt and it looks a little bit better. Now, on the side that our switches are on, as you can see, the board is blank. If you flip this over, on the battery cover side, you'll see your sensor there. Put that up here. That's the actual sensor. Point of this whole thing is that you want to get airflow across that sensor tip and not hitting it from the back. When you hit it from the back, it's not going to allow any airflow over the sensor tip, and you're not going to get a good accurate reading. So just make sure when you place these probes, however you're going to place them, we're going to go into that in just a sec, we need airflow over that sensor tip. Remember that. So in placing these probes, where to put them? As far as the return goes, you can go into the ductwork if you so choose so. If not, you can always place this behind the filter, on top of the filter, or simply insert it into the grill. We just need to get airflow over the tip of this. Now in the supply is one of the most sensitive ones. A while back, what we had was everybody was drilling holes in the ductwork, and they were placing the probe right above the coil. I'm going to use myself on as an example of the coil, and people were putting this thing right up above. Well, placing that sensor right up above the coil, it will have the temperature is going to be very, very low, and it's also going to be very saturated air. If it's in a point where we're actually making condensate, that air coming off that coil is actually going to be 100% relative humidity. It's going to be completely saturated. You're not going to get a good accurate measurement. To get the proper supply temperature where this needs to be placed, you're looking at about 10 to 15 feet down the line. If you must do it in an attic, or if you just need to get into that ductwork, get it away from that coil a bit to allow for air mixture so we can get a good accurate reading. Now, in residences or even businesses, you can use the first available supply register off the plant. And that's going to be more apt to be a lot more accurate. And also, this is the actual product that you're giving to the person occupying that building, whether it's a residence or a business. So, probe placement, very important. If you do get too close to the coil, you're going to see that you've got very low air temperature. You've got also very saturated, and it's going to show up as low airflow 9 out of 10 times. So getting the probes placed in the right places, it's going to make a big difference in what you're doing. So, is there any questions on those? Looks like we've got no questions.
It looks good, Eric. We don't have any questions flowing yet, so you're doing well.
Okay, so what we're going to talk about now is we're going to go into equipment profiling. Now, profiling is simply what the system is consisted of. What's the refrigerant? What's the is it a heat pump? Is it straight air AC? What type of an expansion? Is it an expansion valve, or is it a fixed orifice? And it's going to ask the efficiency. Now, you should probably only run into about 8 different profiles if you're doing residential light commercial air conditioning work. You'll have R22 410A, whether it's going to be a fixed orifice or a heat pump. I mean, a fixed orifice or an expansion valve, heat pump, straight cool, 13 to 16 SEER, 10 to 12 SEER, whatever it may be. We're going to go over putting in these profiles right now and show you how easy it is to access those things again. So right now, I'm going to go ahead and share my screen with you so you can get my iManifold screen. All right.
Yep, we've got it, Eric. That looks good.
Perfect. Right now, I'm going to put in some, well, we'll just start with a profile here. As you can see up on the top of the screen here, we've got our refrigerant. This is our troubleshooting triangle. For this right now, I'm going to go ahead and shut off that triangle. So I went over here to my gear menu, going into tools, I'm going to go ahead and shut troubleshooting off. Shutting that off, I've got a good clear screen up here so you can see what we're doing up here. So right now we're just going to say that we're approaching a job site. We take a look at what we have. We've got a 14 SEER 410A heat pump with an expansion valve, and we're going to go ahead and profile the system. So up here on our bar menu, we're going to open this up, and as you can see, our second tab here is equipment profiling. We're going to open up equipment profiling. And as you can see, there's already some of these that are in your system. These are all defaults. And right here, you'll see a little pencil here. If I tap that pencil, I can delete it or I can edit that profile. I'm going to go ahead and take that profile out just to show you. We can delete these profiles. And we can make new. We can get rid of all of them. We can make all new ones if you like. That's entirely up to the user. So right now, I'm going to profile a new system. This is going to be the heat pump. As you can see, we don't, actually, I did put one in. Sorry. We're going to get rid of it. So right now, everything is straight cool. That's in my profiles. We're going to go ahead and profile a new system. As soon as you tap that, it's going to ask you what you're looking for on this profile. It's very simple, just touching these all the way down. And then when we get to the bottom, we're going to create this quick profile that will be stored into our application. So to start off with this, we have our refrigerant. If you want to change up that refrigerant, you're going to tap this box and you can choose from any refrigerant you got. If it's a 22 system 410A, if it's a 407C, I mean, whatever you want, 421A, you can always change these up too. So we're going to go ahead and go with 410A. Once you select it, it will populate and it'll stay. Now for the system type, whether it's AC, heat pump, or low temp refrigeration, we're going to select a heat pump here. And what mode is it in? We're checking this in cooling mode or heating mode. Heating mode kind of comes into a different aspect ratio as far as what your targets may be. We're going to go into cooling. So cooling is selected. Now our indoor metering device on the coil, on the evaporator coil, this particular unit, we're looking at a standard TXV. Now you'll see this system target, right under system targets here, you'll see benchmark. Benchmarking, we're not going to use that at the moment. Benchmarking is once you've got a good established system and you're working down the line, say you've got a tract housing project and you're looking at 20 different units going down the line that all have the same design, same units and everything, you can benchmark a system that you've profiled, the performance of it, benchmark it, and that way it'll set targets for the other ones that you're going down to do service on or commission, either way. So right here, we're going to go into condenser type. Now, custom condenser, we use that for low temp refrigeration. On our just standard HVAC stuff for residential and light commercial, we have our different efficiencies here, 6 to 8, 10 to 12, 13 to 16, and 18 to 22 SEER. Now, if you're doing say a 7.5 ton commercial unit, you can see what the design temperature differential is off the nameplate. We're going to go ahead and select a 13 to 16 SEER high efficiency heat pump here. Head pressure controls. This is another tab that is actually geared more towards low temp refrigeration, as it's asking about fan cycling, speed controls, dampers, condenser flooding. So that you won't be using either. Now your evaporator. Custom evap is another thing for low temp refrigeration. We'd be looking more into the high latent, standard operation, and high sensible. 90% of the time, that ratio is getting a little bit changing up a bit more because of the higher efficiency systems are using say, a 3.5 ton condenser and a 5 ton evaporator to achieve the efficiency that they need to. Now, if it's matched up, say a 3 ton and a 3 ton, you're going to use standard operation. If it is in that sort where you're using a 3 ton condenser and a 5 ton evaporator, then you're going to go ahead and go to high sensible capacity. We're going to use standard operation. Now, superheating subcooling. These are movable targets. If it's a fixed orifice, your superheat will get calculated. Your target subcooling. Base those things off of what you have on the nameplate, the design on the nameplate from the manufacturer. You can't go wrong with that. If the subcooling target is 10, so be it. If you need to change it and it's 15, you can always select that. We'll keep it at 15 right now for this. Nominal tonnage here. This is something where a lot of y'all have had questions before about the nominal tonnage, entering it in on the profile. When you put in a nominal tonnage on a profile, it does not save it to the profile. Otherwise, you would have probably 6 or 8 different profiles for this same heat pump, being a 3.5, 4, 5, 6, 7.5, 10 ton, whatever it might be. You'd have all these profiles, and you'd have to look down to see what tonnage you're looking at. So the profile itself is a one touch, and then I'll show you just after this how we put in our tonnage. So as you can see, nominal tonnage, optional, not saved to quick profile. We're going to create a quick profile to save this in our list of profiles. I select quick profile, and that little button, I'm not sure if anybody here has been on any of our training sessions. That button right there, submit, is your best friend. You hit that button just to make sure you get everything entered in, and we're going to create a quick profile. This is just confirming that is what our intentions are. So we tab up yes. Now we can use 2 different ways to do this. We can go and name it ourselves, or we can go ahead and auto name. And the auto name is just going to give it kind of an abbreviation. It'll give it easy to identify nomenclature up on the top. So rather than just entering in a name, I'm going to go ahead and use auto name. And as you can see, using auto name, I've got a 13 to 16 SEER heat pump in cooling mode with a TXV as our metering device. So with this, the profile is set. Now to enter tonnage. So we're back up to our bar menu. Open up our bar menu. Go down here to measurements. Open up our measurements. And we see airflow and nominal tonnage. We select it. If you're using your supply and return probes, your 911Ms, you're going to be doing estimated auto calculated for your airflow. We need to put a parameter in here to measure this, a nominal tonnage for say. So this box right here, we're going to tap that box. We'll get a keypad up here. Now, mind you, this is in tons. It's not in BTUs. Putting in tonnage, if it's a 3 ton, just put in a 3. Go ahead and hit next, and then, of course, submit. If it's a 3.5, put 3.5. It's a 7.5, put 7.5. Do not put BTUs in there. You put in 36,000, it's going to be looking for 36,000 tons of airflow. Don't want to do that unless you're working with some monster system. So we're going to go ahead and use 3 here. So we have our 3 tons in here for nominal tonnage. And we're going to go ahead and submit. So now with the way we have a profile set in here, we're set up to work on a 13 to 16 SEER heat pump in cooling mode with a TXV. Right now we just put in 3 tons of cooling, what we're looking for. This is a 3 ton system that we're looking at. Right now, you are set up to go to start analyzing this system. Now, if you notice, if you open up the bar menu again here, you'll see under your quick profiles, this one's highlighted. So it identifies which one you're working with. Now, if we worked and we finished up on this job, we're going to go ahead and get out of this. I just shut down my iManifold. That way, when you go back in, we come back up, we reopen up our manifold. Right now, we're back to our regular screen. We come back up to the same type of unit. Open up our bar menu, go to equipment profiling, and as you can see, there's our 13 to 16 SEER heat pump and cooling mode, 410A with a TXV. It's that simple to take a look at what you got to work with, select it, and your profile's up. Take a look at the plate, look at the evaporator, verify what tonnage that you're working on, go into measurements, airflow and nominal tonnage, select your nominal tonnage, put in what you're working with, and hit that ever-loving little buddy up here, Mr. Submit, and you're set. That's how quick and easy it is to set up a profile. Now, you can set up a bunch of different profiles if you've got straight cool, heat pumps, if it's a different refrigerant, put it in there. Just remember, when you select it, all you have to do after you select is put in your tonnage. So now what I'm going to do is I'm going to put in some demonstration measurements here. We're going to put in some demo data. Any of you can do this. When you go to measurements page, go all the way to the bottom, and you'll see this demo data. And I'm going to select here the AC 410A 16 SEER with a TXV. Now, mind you, what we did here, whether it's AC or heat pump, depending upon if it goes into a reverse cycle or anything else, you're still looking at basically the same thing. We can change that too. If we looked at this heat pump and we wanted to go to straight cool, we can always edit that current profile. As you can see, we've got edit current profile, and I can switch from heat pump to air conditioning and submit. Oops, sorry. It's going to ask us our evaporator again, and of course, as you can see with the straight cool, now our target superheat is calculated for us. There's our target on our subcooling. And we submit. Information's there, system's running. We've got our low side pressure, high side pressure, saturation temperatures, our superheat, our subcooling. Now across the menu bar, across the bottom here, we've got all of our, we've got active temperatures. Now we can scroll left or right. You can finger swipe over on your smart device, or you can simply touch these arrows on either the left or the right hand side. So I'm going to go to the left side. There's our performance there. 2.85 tons, 34,253 BTUs, 20-degree split with a 10.93 ER. Now, mind you, when I put in this information, that loaded up an electrical measurement, already puts in a measurement as far as our air side goes, with a 75-degree return air, with a 55-degree supply air, and go back over here. There's our targets. When we have everything all hooked up, these are our targets here, these little tic tacs. Also, you'll see in the middle of the screen the graphic display as far as the superheat, the airflow, discharge line temperature, and subcooling temperatures. The way these are designed, if there's a scale there, we've got a target here of 15 on our subcooling. So this this gauge right here, what we've done is we've doubled that value. So this is 0 all the way up to 30. On the airflow side, this is high airflow, this is low airflow. On our superheat, as you can see, our target superheat is 14.5, this 10.8, the scale's reversed. This is up high, this is down low. Discharge line temperature, you're looking at, we're looking at 170 degrees. Now, normal discharge line temperature is going to be right in there, 160 to 170. On your discharge line temperature. Anything above, you're starting to look at a restriction. Anything down below, you've got liquid coming through it. Does anybody have any questions on that? Because we've still got a little bit of time. We can go into a few other things. We can go into doing a report. We can move some things around. So
Very nice, Eric. You've covered a lot of good ground, and you've got the audience paying close attention. And I don't see any questions right at this point. If you've got any questions, you guys, you can put it right in the chat. And Eric, while we're waiting for questions, I've got a special offer that I was going to email to the folks who are on this morning's session. And I'll just mention it quickly here. We're going to give a iManifold gift certificate away to any of you from this morning's session that are willing to do a short 10-minute interview with us so that we can talk to you about how you heard about the iManifold and how it's working for you. So I'll send the details on that in an email, but I just wanted to mention that, Eric. They'll get a $50 gift certificate they can use at our e-commerce store.
Well, that's nice. Can I do one of those too?
You have to have more iManifold gear than anyone in the world.
Oh my gosh. Well then, with this, if nobody has any questions regarding that, we can go into making, bouncing over to a quick report, or we can do a little, with, advanced cloud, we can display up some of our advanced reports.
You do have one question there, Eric, on troubleshooting.
On troubleshooting?
Yeah, do you see it there? Shane's wondering when you, when it says check probe placement, is that the 911M or the thermistor?
That could be both actually, okay? Because if you're getting low evap temperature with high saturation, it'll show up on that as well. And they want you to just double check where your probe placement is. If you're getting high liquid line temperature, or low suction line temperature, they want you to take a look at probe placement, because I do get calls kind of regular about, I've got, everything's working fine. My split's great. Amperage on the system looks good. But I've got I've got high subcooling. I mean, it's through the roof. And when it comes down to it, I've got low subcooling. What's going on with that? It was a lot about their probe placement. I've had somebody ask me, said, well, why am I getting all this? This is so erratic. What's going on with it? And I said, well, where are you taking your temperatures? Give me an idea. I said, well, what are your temperatures? And he says, well, my suction line temp is 54 degrees, and my liquid line temperature is 160 degrees. And that has literally happened over in New Mexico. I got a phone call. Well, he's taking discharge line temperature. I mean, he's 8 inches away from the stub of the compressor. So probe placement, that's one of the things. So get in the right place, everything's looking good then. Everything was right. He did a great tune on it. He just had his thermistors in the wrong places. So if on troubleshoot it says check your probe placement, just verify your probe placement, make sure that those sensors are in the airflow. That's another thing. It's okay when they're faced straight in. You're getting airflow over it. It's when you've got something that's a bit higher velocity and it's facing this way. You're not getting enough air over that sensor chip. So probe placement, it wants you to double check those. Troubleshooting doesn't tell you exactly what it is. It's going to tell you to check your probe placement. It'll give you a kind of a view of what you need to be checking on. So it's not going to pinpoint it.
Eric, you've got another question. How do you get a superheat target to be a spread, i.e. 5 to 15?
That's an algorithm that is put into the system, and it's based on all your temperature measurements. So it's calculated within the system about what your superheat should be.
Okay, and then we've got another question.
Pretty cool, of course.
Another question from Ken. Can you go over the center bars when high is on the top or bottom?
What do you mean high is on the top? Well, on this right here, can you see my cursor there, the little finger?
Yep, that's showing up.
Okay. So this center bar right here that we're looking at, this is our superheat. That center bar right here, this would go up to high superheat, and this is low superheat on the top. Discharge line temperature, high discharge line temperature, low discharge line temperature. Now on the bottom here, we might want to consider reversing it, because over here we've got high airflow, and then down low is low airflow, but on our subcooling, going towards the bottom here to the SC is high subcooling, and this is low subcooling. You know, and that's something that it's an aesthetic thing. So if we did go across here to our targets here, as you can see, this is what we're making. We've got 16.3 degrees of subcooling, but our target is 15. And as you can see, this drops down lower here. So I see, John, what you're saying, because this is low, this is high. I mean, this is low towards the AF, and this is high on the airflow. Is that what you were looking for on that, John?
I think that was Ken that was asking about the center bars.
Sorry about that.
Okay, so Eric, you've got about 10 more minutes. Do you want to cover one more topic for us?
Oh, we got one more question here. I guess that wasn't a question. Okay, good. What we can go over right now, we can simulate some troubleshooting. So here our troubleshooting triangle is up, and we got check mark because everything falls within parameter. Everything's close enough to say that the system is operating normally. If I tap that triangle, as you can see, the system's operating normally. Our suction pressure is good, head pressure is good, superheat, subcooling, they're all within target range. Well, we can throw these things out of target range by going over here, and we're going to do some adjustments. Now, mind you, this is demo data, so we can manipulate it. Now, when we manipulate that data, it's not going to change the capacity because, like I said, this is just data going in here. And we're not running live, so it's not going to affect anything here. So our pressures here, we're gonna overcharge this. On our high pressure side, we're going to go to 385 and submit that. Now, as you can see, when we did that, our pressures went up. We went up to 385. Our target's 342. We're out of parameter here. And as you can see, when we did that, now we've got 23.8 degrees of subcooling when our target was 15. So now going up to our troubleshooting triangle, we tap the triangle. System is exhibiting symptoms of a refrigerant overcharge. Our suction pressure is okay. Our superheat is okay. Head pressure is high and our subcooling is high. So these red boxes, we can tap the red box. And tapping the red box here, hold on, it's not showing up on your screen yet. There it is, high liquid discharge pressure. It'll give you just about a textbook definition of what's going on. Now, I know seasoned technicians, they're going to know what's going on already. If you want a little refresher course, there you go on that. So we can hit OK. It'll knock this out. Subcooling, same thing. It'll give you a nice little definition here. We tap OK and get out. And now on anywhere you see these eyes, That's information. So we can get a whole look at what's going on here. So we tap this box. A little screen delay. Diagnosis. System measurements indicates that it is overcharged, too much refrigerant. Here's the symptoms, operational characteristics, and a recommendation as to how to fix it. Now, if there's a more complicated issue, it's just like, it's not pinpointing you exactly. This is a very simple one. We can detect, I think we've got just about 50 issues or more that we can detect. It'll help you with troubleshooting, from compressor running inefficiently to TXV issues. There's several issues out there. It'll help you out, but it's not going to pinpoint necessarily and tell you, okay, this is how to do this. Take 3 turns at your TXV and you'll be fine. It's not going to do that. But what it will do, it'll take a problem that's this big, whatever you're looking at, the parameter of what it could be, and it'll narrow it down to this. So it'll speed you up, help you out, give you a better point as to where to start looking for that issue. So if we want to get out of that, we'll just hit iManifold. We're back into iManifold. Did we have a question up there, Laura?
Yeah, we've got a good question. I'm wondering if there's any plans for future classes that'll be geared toward the refrigeration guys. That's an excellent question.
There is. Right now, we're working on the application a little bit more. We're streamlining up just for the refrigeration guys and going after some different temperature sensors, because in the refrigeration industry, of course, you don't have air over on a lot of evaporators. We're going to be using surface probes. There's going to be different mapping on our sensors. And that is, we're real excited about that, because that's a question that's been out there for a long time now. And we're going to get our system up to speed and very, very low temp refrigeration friendly. We work in ice machines, reach-ins, walk-ins, I mean, everything. So yes, that is coming up.
Great. We'll make sure to notify you when that's available. And Eric, you also have a question from Bart. Can you explain benchmarks again?
Okay, benchmarking. When we're working on systems, and say there's you can go from 3 like systems on a house. They're 3-ton 16 SEER systems, and they're all by the same manufacturer. They pretty much have the same specs on these things. You can tune this one up to just be perfect. This thing's running perfectly. We've got this, and we can benchmark, like right now, this right here, what we're working with, I can benchmark this one, even though it's running at high head pressure and everything. I can benchmark this because this is as good as we can get this thing running. Let me show you that. As you can see, we have a tab for benchmarking. So this system I'm working with right now, I can benchmark the system right here the way it is. Of course, it is not running properly, but under, depending upon the conditions where you're at, you can tune this to where it's just optimum on your split. You've got a 22-degree split. Your pressures look great. Everything's awesome. You can benchmark the system. I'm going to do a fake benchmark right here, and you'll see what happens. As you can see, we've got our troubleshooting tab is up. Our pressures are actually high, but if I benchmark this, save and update. As you can see what happened, when targets go into play, even though that the system wasn't right, per se, it benchmarked it. So if you don't have all the information, you can super tune a system, benchmark it, go to that next system that's similar, and you've got all the information that you had on the system that you've got super tuned, and you can match it. But like I said, on this one, that 385, that's high head pressure. Subcooling, I haven't seen a system out there, residential system out there, that has a 23.8 degree subcooling target. you know, that's for sure. So we can go back in and eliminate that as well. When we go into this profile, sorry about that. Edit that current profile. As you can see, when we did do that, that benchmark, it turned it into a custom condenser and a custom evaporator because that falls out of the norm. So we can shut these off again, keep our 13 to 16s here, shut that off as well. Go to our standard operation, go back into our subcooling, eliminate that 23.8, get our 15 back in, and submit it. Whoops. And there we are.
Thank you, Eric. That's been a wonderful session. We're near the end here, and I know you've got to run for your flight.
Yeah, if anybody's out in the North Carolina area, I'll be out there. Give me a buzz. I'll tell you where we're at. We've got kind of a full house over there. We've got 2 sessions, 60 contractors, and I'm sure there's going to be some no-shows. So I will be in Raleigh, North Carolina. I get in today. The training starts tomorrow. If you give me a buzz, my information is available online. You can get a hold of me directly, or just post it on here to on our website at iManifold.com and go to Tech Talk and just gear at North Carolina training. I'll keep an eye out and we'll see if anybody's out there. Come on by. We're going to do a start to finish commissioning class. So.
Terrific. Well, thank you everyone for joining us this morning. And thank you so much, Eric, for leading us through this early on your morning day, and have a great travel the rest of your day and good training.
Thanks, everybody. If you have questions, Tech Talk, reach out to us by phone, however you want.